The question says that a spring having a spring constant of 1200 Newton per meter is mounted on the horizontal table as shown in figure 13.19. A mass 3 kg is attached to free end of the spring. The mass is then pulled sideways to the distance of 2 cm and then released. Now we have to determine the frequency of the oscillation, the maximum acceleration of the mass, and the maximum speed of the mass. So let us recall the formulas that is used to calculate these values. So we know that in SHM, angular frequency can be written as omega, and that is equals to 2 pi by t. Now for the spring mass system, we know that omega can be written as root under k by m. Now from this we can infer the frequency as 1 by t, and that would be equal to 1 by 2 pi root under k by m. So we can calculate frequency with this formula. Now for maximum acceleration, we know that we haven't given the displacement. So maximum acceleration in SHM is omega square a, that is a is the amplitude, and x max here is given as 0.02 meter. So we can calculate maximum acceleration, magnitude of maximum acceleration as this. Now the maximum speed can be given as V max can be given as omega times a, which is upon calculation of omega we can calculate this value as well. Now the first thing that we have to calculate over here is omega. Now omega can be calculated as per the given data. We have been given that spring constant is 1200 Newton per meter. So omega would be equal to root under 1200 divided by mass, that is 3 kg. So it would be equal to, so upon calculating this would be equal to 400, that is equals to 20 radian per second. Now calculation of frequency, we can calculate this as we know the value of 2 pi by m, so that would be equal to 20 by 2 pi, and that equals 3.18 hertz. So this is the solution for the frequency. Now we have to calculate maximum acceleration. Now maximum acceleration is omega square a. We have the value of omega, so we can calculate a max as 20 square multiplied by amplitude, that is 0.02 meter. Now upon calculation this we can get a meter per second square, 8 meter per second square. Now calculation of V max, we know it is a omega. Now substituting those values, we get maximum speed of the mass as 20 times 0.02 meter per second, and that is equals to 0.4 meter per second. Thank you.